Hey, we are in section 5.4. We're working on logarithmic properties. 5.3, we learned just what a logarithm was and some of its properties, but now we're doing some of the more advanced properties. So number 7 and 8 kind of shift gears slightly, so I just wanted to change the video. Now, this is going in reverse, like instead of using a logarithmic property to simplify it, we're actually using a logarithmic property to bring it back together instead of take it apart. Just do a quick example here, number 7. So the log of 100,000 minus the log of 100. These are both the base 10 common logarithms. And so what the log rule is that the difference of two logarithms is actually the quotient. I'll put the base there just so you are aware of it. It's the quotient of the two logs. Now, not of the logs individually, but the arguments of the log. And which really makes this problem really easy. So the difference between those two logs, those cancel, and you get the log of 1,000. We all know what that is now. Base 10, that is 3. So this is it expresses a single logarithm if possible. They're really that would be right here. You put the 100,000 divided by 100. And if you simplify your answer, you get 3. So anyway, so that's number 7. Number 8's the same kind of thing, but now this time we're going to use the property that the multiple on the outside can come in as an exponent. So keep in mind this is this idea of we're going in reverse now of what we're seeing in problems 1 through 6. All right, so let's see. These are both common logarithms. There's no base stated. You bring the 1/2 on the inside of that logarithm, and you bring that 7 on the inside of that logarithm. All right, and now we're not done because that's the sum of two logarithms. Now, it takes some getting used to. When can you use these properties and when can you not? But in this case, the sum of two logarithms is the log of the product. You've got to be careful about what's the product and what's the sum, but the log of a product is the sum of the logarithms. And I think that's all we were wanting there. So it expresses a single logarithm. We have achieved that. It's log b to the 1/2 c to the 7. All right, let's keep going with this single logarithm thing. I think you're going to get used to it. Number 9, so this is the natural logarithm now, that ln, that's base e, and I got some crazy exponents going on with this one. All right, let's do this. All right, now that exponent is already on the inside. We're actually going to leave it, but that 5 needs to come in before we use the difference of the two logarithms. With that 5 there, it's not quite the difference of two logarithms. So you bring the 5 in. Now, watch this. Watch carefully here. This is x cubed to the 1/5 to the 5th. Crazy. I brought the 5 in. I didn't bring the negative in. I just brought the 5 in as an exponent. Those are going to cancel each other. So you're left with the ln of x to the 4th minus ln x to the 3. Now I'm using more log rules. The difference of two logarithms, now we don't have that 5 there anymore, is the quotient, the logarithm of the quotient, which those cancel. 3 goes into there, leaving you ln of x. So that reduced a whole lot, and so the answer to this one, which it doesn't look like it would be that simple, the ln of x. All right. Number 10 is also express as a single logarithm. So let's complete that task. We have the ln of x minus 7. Let me go ahead and send that. No, wait. Sorry, I was gonna send the 7 through the parentheses, but I decided it wasn't necessary at this juncture. Okay, so there's our problem. So I'm not going to do anything with the ln of x or the 7 yet. First, I'm going to take care of these brackets. The bracket says the sum of two logarithms is the logarithm of the product. X minus 3, x plus 3, like so. All right, next I'm going to bring the 7 on the inside, like we've been seeing. So that's going to make this x minus 3 to the 7th, x plus 3 to the 7th. All right, that 7 hits everything in there. That's a product. Go back to your exponent rules. Make sure you understand those. And then to complete, we just need to use the difference of the two logarithms is the quotient. Logarithm of the quotient. And there's our final answer on number 10. Number 10, again, a little lengthy, is the ln of x divided by x minus 3 to the 7, x plus 3 to the 7. And the answers are at the end of this file, so if you ever want to see how you're doing, just check that out. All right, these are going to be kind of quick, so let's see. So why don't we just fly through 11 through 15, because they use the same property over and over again, and I think you're going to catch on really quickly. So number 11 is log of p squared. Now, remember, logarithms are exponents. If you look at the properties of logarithms, the one that we're going to be looking at right here is this one, the inverse logarithm. The log base a of a to the r is just r, and the a to the log base a of r is just r. They cancel each other out. You see those green slashes there. They are inverses of one another. So back to the problem at hand, that log base p cancels that p, leaving you just a 2. Now, if you're not comfortable with what I just did, just go ahead and convert p to what power is p squared, and the answer is, well, y is equal to 2, and we'd be saying y is that logarithm. All right, so that's number 11. 12. So we can do these a little more quickly. Let me make it a little bit bigger, and so those cancel each other. You just get 2. These cancel each other. You just get 2x minus 2. These cancel each other. You just get b. You gotta be careful there. It does cancel with the base, but you have to rewrite the exponent up there. And so this cancels with that, leaving you a 6th. This cancels with that, leaving you 10 equals 2x, which means x equals 5. So the solution to that equation is 5. Hey, thanks for watching.